Hello everyone, welcome to my channel. Today we will be discussing the RMO 2024 problem 6. The problem is on your board and then you can read the problem for yourself and we'll discuss the solution. You can pause the video and try it for yourself. So we'll start with the solution. First we will prove a claim which states that for any number which is power of 2, so for example 2 power n, right? The f of that 2 power n is 2 power m minus 1, okay? Now the proof goes as follows. So first notice that if a number is the form of 2 power m, then all the divisors divisors of 2 power m will be in a sequence, but divisors of 2 power m will be of form 2 power some power of 2 only, right? So for example, divisors of 8 are 4 and 2, right? Okay, so we can write any 2 power m chain as this thing 2 power 0, this is 1, so 1 से start कर रहे हैं and then we can go up to 2 power m, right? And we have to fill in some k minus 1 people, but k is also from up to 2 power m. So we have to basically choose powers of 2 to fill in the sequence. Okay, now we can either choose a power or we cannot choose a power, right? So from 1 to m minus 1 you can either choose a power or not choose a power. That is, so basically you have two choices for every m minus 1 thing, and hence the total number of ways to do it is 2 power m minus 1. Now I just explain this claim for m equal to 2 once. So for example, m equals 2, then f of 4 equals 2, right? So if f of 4 equals 2, that corresponds to 1 comma 4 in this case. From so basically 2 m minus 1 here, since m is 2, m minus 1 is 1, so you have to choose from the set 2 itself. So you have two choices, to either choose 2 in it or not choose 2 in it. So either you not choose 2 or you can choose 2. So that's why you have two ways, and that is why f of 4 is 2. So now we'll proceed with the next part. So now we proceed with the second part of the solution. Okay, now there are two cases, right? So since all of them are divisors, notice that if we have a n chain for some n, then like if you take the previous term ak minus 1 or the term, that so 1 to ak minus 1, that term will also be actually an n chain for like ak minus 1, right? So that is why we can kind of use a induction kind of argument. Matlab, that is how you can think about it. There are two cases in which we divide the problem now. First case, when the term after 3 into 2 power n is divisible by 3, and the second case when it is not divisible by 3, right? So if for example if it is not divisible by 3, then it has to be divisible by 2 power t, right? So 3 into 2 power n and then some 2 power t, and for now we'll take t to be vary from 1 to n. T equal to 0 is also valid and we'll include that later, right? So t can vary from 1 to n, and notice that after we have 2 power t, then we can fill the terms according to the divisors of 2 power t. So that is a 2 power t chain. So we include the number of 2 power t chains, right? And then accordingly you can just take the sum. Since we know that f of 2 power t is 2 power t minus 1, so this sum just becomes the summation 2 power m minus 1 to 1, and then this is 2 power m minus 1 is the GP, right? This is a very simple GP. Okay, now we take the second case where the second term is also divisible by 3. So the thing is, this is 3 into 2 power m and this is 3 into 2 power j for some j less than m, right? Now this thing is nothing but f of 2 power j, right? The number of sequences of this form will be f of 3 into 2 power j, and that I just write it as a sum, right? Frankly, you can just write it as a sum. And now we'll use induction. So what we have done till now is that we have f of 3 into 2 power n equal to f of 3 plus f of 6 plus so on till f of 3 into 2 power n minus 1 plus 2 power n minus 1 cases from here, plus the one case where you have the number and then 1, like for example 6 and then 1, right? That is also a valid case. I just explain this thing for m equal to 2, right? Okay, sorry, m equal to 1. So for m equal to 0 it is quite trivial, because I mean you can just take f of 3 equal to 3 into 2 power minus 1 into 2, although they have specified m to be natural, but I mean this also works. So f of 3 equals 1, and that is quite trivial to note because 1 and 3 is the only sequence. Okay, and for 6 if we go, then the sequences are 1 comma 6, 1 comma 2 comma 6, which comes from this case, 1 comma 3 comma 6, which comes from here, and this thing is accounted in the end, right? So that gives us 3 solution. And if you put m equal to 1, right, then 3 in f of 6 equals 2 power 0 times 3. So f of 6 equals 3. So it is valid, right? So now we are on the right track, and we have to just prove this thing by using induction. And now we'll proceed with the induction proof. So welcome back to the channel. We'll just finish off the RMO problem 6, and here's the rest of the solution. So we had pretty much got a recursive thing for the function, and now we just use induction. So m equal to 1 is what we have already done, right? Which is basically computing f of 6. So yeah, that we have done in this earlier part of the video. And f of 3 times 2 to the m is 1 plus 2 per m minus 1. This thing is basically we have done in the last video. The entire thing is to basically compute this sum, and this is basically the sum of an AGP. You can rewrite this as telescoping, and then you can rearrange this to get a telescoping minus a GP sum plus a GP sum and some 2 power m plus 1. And then this sum is basically 2 plus 2 square plus 1 till 2 power m minus 1, just 2 power m minus 2. And then accordingly this is just the telescoping, and this is like the GP ka sum. So this starts from 2 power 0 like 2 power m minus 2, and then that comes out to 2 power m minus 1 minus 1. Know that this proof is valid only if m is greater than 1, and m greater than equal to 1, like m cannot be 1, m has to be greater than 1, because or else this sum will not be a valid sum, right? So that is there, but yeah, m greater than 1, then it's valid, and then you get this sum if you just simplify this expression, and then you got it. So that was the solution. If you find any better solutions than this, or any other ideas from this problem, it's more like a combi problem plus recursion, more of a combi problem. So I hope you understood the solution. Thank you for watching. Like and subscribe the channel.